Thanks for joining our conversation today about digital twin. I'm Joseph Lewin with Cadena's Part Solutions, and I'm here with Jennifer Herron and Rhiannon Gallagher from Action Engineering. So why don't you guys just go ahead real quick and introduce yourselves?
Me first? Yep. All right. Jennifer Herron, Action Engineering, CEO and founder, and here to kind of represent the technical side. Rhiannon will represent people because they're the other half of this complicated puzzle. So Action Engineering is a company that is helping businesses transform their manufacturing activities to utilize 3D data that comes in all different model flavors, but 3D data that can be used and reused throughout their organization.
Awesome.
And I'm Rhiannon Gallagher. I'm the Chief Social Scientist at Action Engineering, which means that I do all the pieces of this transformation that don't involve data, basically, that involve people. And I was thinking in preparation for this, I've been doing digital transformation, helping people with digital transformations for more than 20 years now.
Oh, wow.
In various industries. So yeah, manufacturing's kind of last to the game, but but that may be a good thing. There's some stuff to learn from what everybody else has done wrong. So
yeah, that's fun.
Well, and when you say you don't deal with data, that's not exactly true because you have to know the data to interpret the information people are using.
Yeah, social scientist at an engineering company. That's kind of a fun mix you don't normally see, right?
Right.
It's pretty unusual.
Yeah, I love it. Well, I'm excited to get your input on today's conversation as well. Yeah, and I guess I didn't really introduce myself. I'm a marketing manager here at Cadena's. Awesome. So we're just going to start off super high level with what is a digital twin?
Okay, so I'll take that one, and I have props. So a digital twin is basically a digital representation in any kind of data format of a thing. So this is our classic pump assembly that we use at Action Engineering in all of our training examples and education materials. And so we've got several parts in here, and each of these parts will have a digital representation. So Joseph, for you guys, there's your parts. The standard parts,
Absolutely.
The fasteners and the washers are the parts that the Part Solutions tool help to add to this assembly. And then the other parts are parts that, Pump Acme Design Company would be building and generating. So, but this is the physical representation, and then anything we create digitally is really a digital twin.
Yeah, that makes sense. It's kind of like, and then I guess to build on that, what would be some examples of why you would want to have a digital twin? Like, what does that do for you?
Yeah, well, the three primary ones that we work with the most are in design, fabrication, and inspection. So it's the design aspects. We want to be able to capture all the engineering requirements for each of the components in this assembly. And then when it gets sent to the fabricator, then they create their own 3D instructions, in-process models about how this part is built. And then the third one is primarily for inspection. And in inspection, that is a combination of the engineering requirements plus the measurement results and other inspection data that gets added to the engineering requirements together, and then that becomes the 3D quality digital twin.
Okay.
So, yeah.
Yeah, and maybe you could speak to this too. Another reason for having a digital twin that I've heard of would be like the GE Aviation example, where they make a digital twin of every engine that goes out, and then they feed data from every single flight back to their digital twin of the engine, and they're able to run simulations to see when maintenance will need to be done on each particular engine. So I'm sure they're creating a digital twin while they're in the design phase for the overall engine design. But then each engine that goes out on every plane has a representation digitally, and then on
Right.
every flight they're collecting data, and they're able to update maintenance schedules based on the digital twin.
Yeah, because once you have the 3D representation, so kind of what you're talking about is that design engineering 3D representation of the engine. Pretend this is an engine, even though it's a pump. But if we have used this pump as an example, if I take this pump and I have real-time sensors in the field giving me data on it, now I have the 3D representation, digital information, where I can simulate the results and find out what's happening. We can do predictive maintenance. We can do catastrophic, analysis of failures. There's all sorts of opportunity with it, which is kind of why digital twin is a little fuzzy, because there's lots and lots
Right.
of opportunity, and lots of people's brains their juices are flowing. They want to use all this digital data in lots of different ways.
Awesome.
Yeah,
Go ahead.
one of the things that we think about when we talk about this data from a user perspective is that one of the things, the real benefits to it, is that it's very easy for somebody to grasp a 3D version, a digital twin that is a 3D version that they can turn and manipulate, and it makes onboarding people into your manufacturing processes much faster, which is a big issue
wow.
when you have other stresses on your manufacturing processes. I won't name any names, but we know who we're talking about. So so all of that stuff that makes it faster to onboard people and faster for people to understand what's going on and really see the relationship between the physical thing that they're building and the digital thing, that all speeds up and makes more efficient all those processes.
Yeah, that's an excellent point, especially with right now in our it's 2021 right now. We're recording this, and there's labor shortages across the board, but especially in manufacturing, and there's a shortage of younger people going into manufacturing or into more of the trades or blue collar type work of the past, which I know manufacturing today, a lot of facilities look very different than what you would imagine a manufacturing facility would look like, 30, 40, 50 years ago. But with a shortage like that and high turnover, it's even more important that you can onboard people quickly and then they can get up to speed on your products and the process for manufacturing them.
Right. And although, the kids that are coming in, I mean, they all grew up with Minecraft. They're fine.
They're fine.
This digital twin thing, it's not an issue for them, right?
Right.
It's
because we turned it into a video game.
Yeah, because we turned it into a video game.
Right.
It's all very intuitive.
Right.
Yeah, it kind of makes it more exciting that way for them. Okay, so we kind of covered some of the applications for what a digital twin is. And like you said, there's lots of different variations and versions that people use for, virtual testing while they're designing and, being able to do all kinds of stuff with that. But what isn't a digital twin? What are some examples of things that people are calling a digital twin, but, maybe doesn't quite fit the definition?
Well, I think the definition in this state of the industry that we're in is pretty fluid. So I personally wouldn't say there isn't something that matches a digital twin, because I don't think it's a hard and fast representation. I think it's a nice way to conceptually talk about the fact that we are representing physical information in a digital space. And I think there is some definition around it, but I don't think people are necessarily using it consistently through as an actual practice. I think there's a lot of talk about it, but yeah.
It's given that word digital twin has given it a way to sort of be understood across industries, right? Like healthcare is talking about digital twins as well, right? This idea that you would be able to see a scan of yourself and your X-ray data and all of your information that's associated with it, or digital twins of houses where you could sort of walk into the house and design how the kitchen looks by like this. So digital twin becomes this sort of overarching term that's a little bit broader in some ways than Industry 4.0, which has this sort of manufacturing specific designation. And I think that that's helpful for larger contexts and people who don't have an understanding of Industry 4.0 as a phrase. Right. So that's, I think, part of why digital twin comes up so much.
So it's almost
Yeah.
more a term that would be similar to digital transformation because that's goes across industries. It's a very versatile word. I mean, basically, anytime you're
Very. Yeah.
creating a new process that involves digitalization of anything or upgrading from you know, your old school digitalization to the cloud or to, whatever, that all of that gets included into digital transformation. And that's totally digital transformation in engineering and in manufacturing is completely different than digital transformation in accounting or
Right.
in a different field.
It isn't, right? I mean, I was thinking about this today. When I was a student in London 25 years ago, at night in London, there were these little like armored golf carts that would drive all the paper from one bank to another all night long, right? And that was before banking did its digital transformation. And then, legal has done it and medical has
Hmm.
done it. And, and a few years ago, I was working in mining and mining was doing it.
Hmm.
And so all of those transformations, while they are different and they've got their own set of data problems, right? And their data is unique, the things that we've learned from all those transitions are pretty consistent,
Hmm.
right? You have to talk about the people. You have to have leadership that is willing to back the process and back it as an enterprise-wide
Hmm.
process. And you have to recognize that it's not just a tech change where you just put in new piece of software and everybody gets it and you go, right? That stuff is true across all the digital transformations in all the industries I've ever worked at. So yeah, different, but not as different as we might think. And that's great for manufacturing because it means that we've got all this data that we can learn from
Yeah.
in terms of how to do this transformation successfully because all of these other industries have done it before us. So I often think we're inventing wheels when we don't have to, right? There's
Right.
already pretty good wheels out there.
And I do think we tend to overthink the terminology. I mean, I know who you're talking to. It's Jennifer who wrote the MBD dictionary, so I get it. But but I do think in this case, this should be looked at as not so much as this particular definition, but as a concept
Hmm.
of something bigger that we're trying to put in place.
Yeah, that's great. And on the note of digital transformation being consistent across industries, another thing is the quality of data matters and how you
Yes,
manage that data.
very much so.
And,
Yes.
I think for a long time, people were saying you've got to collect as much data as you can on every single little tiny thing. But then all of a sudden you have tons of data that nobody's ever going to use or
Right.
data that doesn't really have enough context around it to be useful or wasn't gathered in a way that was clean enough
Right.
to be useful. And those are all areas in manufacturing, especially where you can collect an endless amount of data. I mean, you can throw sensors on anything and be collecting tons of data, which,
Yeah.
if you end up being able to use that for something in the future, that's great. But it can also lead to spending a lot of money to collect the data and then having a massive problem of, well, what do you even do with all of this data that
Yes.
you've collected?
Yeah, not having a good way to sort of summarize it so that when something happens, your supply chain fails, and you've got to be able to react to that quickly. You've got to be able to get out the distillation of the data that actually matters and say, okay, now we're just going to focus on this piece. And I think sometimes we collect so much that we never get around to that focal point.
Yeah.
Right. Right. And I mean, that is really why we exist as a company, is so that we can teach people how to author data that is useful downstream in an automated way for the machines, but then also for the people. And we try to do 2-for-1s as many times as we can. And we're doing that in a very detailed way across many different types of examples. So like in our pump, like we're looking at the standard piece parts, we're looking at a basic part like a shaft and a bearing that's in here, but we're also looking at something more complex like this casting that's then post machined.
Hmm.
So it takes that level of depth of uh, depth of experience, I guess is the word, but digging into the details of how this data shall be authored in 3D over how it's authored today in 2D, because there's a lot of ambiguity in a 2D drawing. People just don't have any idea how bad their drawings are.
Yeah, I
They're
mean,
terrible.
and
I
on
can
the
guarantee you.
example of your pump there, so our company I guess I'll give just a 20-second overview of what we do. So, we work with companies that manufacture components from fasteners to pumps, bearings,
The pumps,
motors,
yep.
cylinders, all kinds of stuff, and then help create 3D models for them to have on their website. So we've kind of coined the term component digital twins because it does maybe go a little outside of the common definition, but in your definition of digital twin, it fits into there, which would be,
Right.
you have this pump, but then the engineer that's going to design that pump into, whatever their design is going to be, and they're going to purchase that pump from a supplier, maybe not that particular one, but for the example, they are going to buy a pump that might be standard off the shelf, or maybe there's some customization to it, but there's going to be data they might need with that pump. So that they can make sure that it's going to work properly. And then if they're going to run simulations, or they want to put sensors on that model to, run digital twin simulations down the road, they're going to need to know a lot of information about, I don't know the engineering terms for pumps, but, the flow rate or whatever it would be, there's going to be information about that particular part. And in a 2D drawing, you're not going to capture that necessarily. So you'd have to have a booklet of, a PDF data sheet or something with all kinds of extra information that you're going to have to reference. But that information could all be put into that 3D model that the engineer can get and have when they open up the model. And then they could potentially, if it's in the right format, have that model be able to be put right into a design and run simulations without having to do a lot of modification or adding that information in the model down the road. And so that data really does matter. And if that data isn't there, because it's a step file and you can't have some of that metadata and certain, types of, certain models or whatever, then you can't really run that stuff downstream.
Right. Yeah. And I mean, I brought up the design, fabrication, and inspection silos, which end up being people silos too, that Rhiannon has to bust through. But then you bring up the analysis silo as kind of another one that comes sometimes on the front end, sometimes on the back end of the whole product process. And so that fourth silo, there's a lot of opportunity to connect the design requirements in with the analysis pieces, and then the after analysis when you have some kind of predictive maintenance or catastrophic failure kind of analysis that you're trying to perform. Connecting those pieces, there's a lot of opportunity once we get the data digital rather than representing it on 2D drawings.
Absolutely.
There's problems with the data that people have today, and those problems are so ingrained into their processes that they often don't even realize that they're problems.
Right.
So I get the drawing over here, and it's 64 pages, and it's going to take me 3 weeks to figure out exactly what I'm supposed to build. But then also I've got to go over here and get this other set of data that that may be connected to a revision of the drawing that isn't the revision of the drawing that I'm looking at. And so there's a lot of problems in the processes that people have now, but they're so ingrained, these processes, that they feel really efficient and they feel really accurate. One of the interesting things that happens as people convert to digital twins is all that stuff gets exposed. And it's kind of like, how right before you sell your car, you go to detail and you're like, my car's in really good shape. And then you go to detail it right before you sell it. And you're like, oh, except for that. And that, and that thing is coming out, and I forgot about that dent, right? And all this stuff gets uncovered in terms of how the data has been put together that people were sort of working around in their current processes. And then when we convert it to the digital twin, they're like, oh, we've been building things off of this. And there's
and then we start going, wait, we were flying in the thing that you created. That many issues with it. Yeah, I think another piece that kind of comes in with the people and the value of moving from paper to 3D is also the tribal knowledge that's captured in people's heads throughout the process. And then, where you have also some of these major failures is when somebody's been working at a company for 45 years and they have all that information in their head and they leave, and then you're bringing in a much more junior engineer that's supposed to take over from them. And it's like, how do you capture 40 years worth of knowledge in stacks of paper? Whereas if it was in 3D, the metadata was embedded in the models correctly, you could potentially go back and reverse engineer what was going on, because at least the information's there.
Yeah, and I think it goes beyond just having the data in the model. It's that your culture of your company is capturing the information that is important um, in a digital way so that, if you get hit by a bus or you retire the next day, that information is still there and persists throughout the company without you having to interpret it, because the drawings are extremely interpretable. Um, we can always find something that we're like, well, is it this way or is it that way? And then, there's either the supplier that builds your part is going to mess it up or not, they're going to make a poor assumption, not because they're stupid, but because the documentation isn't 100% clear. And so it's having a whole culture of collecting that data so that it persists throughout the company and not just in one person's head, which I understand is very difficult and challenging to extract.
It is, and there's, knowledge is power, and this problem of the tribal knowledge goes all the way through the entire product life cycle. You can find it everywhere, and it's as that generation retires, and as we try to recruit new people in every level, in every role of manufacturing, we keep running into that gap. Where it's like, oh yeah, well, the engineer has been saying to do it this way, but we actually do it this way over here, and only Ernie knows how to do it, and Ernie's not here today, so he can't show you. But normally, okay, let's write this down. Can we write this down somewhere and have it?
How many times has that happened to us, Rhiannon, and how many companies?
Dozens.
All of them?
Every
time.
Yeah.
Yeah, I mean, and then
every time.
You mentioned something also about the supplier building something a certain way based on their interpretation. So you could also run into that problem when you change suppliers and you're assuming that the next supplier is going to interpret the drawing the same way, but they don't. And then now you have, a huge batch of something that doesn't work the same as it did before. And you have supply chain issues because now you have to send those back and, or, have new ones made. And there's a process for that. And so you could run into all kinds of challenges if you're interpreting that wrong.
Yeah, and companies, John Deere and Ford and GM and Toyota, they don't want one supplier to make one part. That's not how they, maintain competitive advantage or retain competitive advantage. They need to be able to go to the best product at the lowest price. And so that's how the supply chain works. So, it's really important that they don't get stuck in sort of this tribal knowledge do loop because they don't have enough digital documentation that can help communicate in a very unambiguous way, because you put everything in a 1 or a 0. So you have to make a choice.
And it, just builds their resiliency, right? If I've got a good solid set of digital twin data, and all of a sudden container ships aren't making it over from China, I can say, all right, who in Canada can make this part, right? That's a conversation that I can have now, knowing that I'm going to be able to package that up tightly and get it to the next supplier down the list that, that isn't sitting in the Port of Long Beach. So, so all of this stuff is about building the resiliency of the entire manufacturing process.
Absolutely. Yeah.
And I think we don't talk about that enough in digital twin. I think we think of it as this thing that we're, this sort of future thing that we've decided we needed to go for because it's the new high tech thing. We don't talk about the importance the real benefits that it can provide in terms of resiliency. And I think we've all learned about resiliency this year. So
yeah, kind of important. Yeah. And there's also a competitive advantage to data. And this is something that I've been talking about with different manufacturing company, industrial marketers at other manufacturing companies that we work with. It's not just your product that has value, but the data and the way you package that data and provide that to the engineer. So if you have data that this engineer needs to be able to run simulations or be able to run things, and they can do that correctly from the get-go, and they know that when they get that model, they've already got everything set through, all these different stages of the product life cycle, whereas your competitor has maybe a similar part, an almost identical part, but the engineer's not able to, they don't necessarily get that data from your competitor. that's a huge competitive advantage. And you might even be able to charge more for your product or just totally outstrip the competition if you're providing that level of data. And more data becomes valuable. And I mean, when I've gone to the PLM conferences, one of the biggest things that I've heard is data and them talking about the importance of quality data. And I mean, PLM companies make their money by storing tons of data, but even for them, they're like, we really need good quality data, and it needs to come from the source. So, there's value in for suppliers to be providing that data as well.
Absolutely, and this is one of my favorite topics this year.
I was going to say,
I just got excited. Well, really, because if we've got the engineering requirements captured here, and then we take this to quality and we capture the inspection results, how this part was actually built, and we create a feedback loop now to the engineering, either the original organization or just me. Like, I'm the designer and I want to know how my part is inspected. This makes me a better engineer because I have feedback about this part and how it was built that I never had before. It allows me opportunity to open up tolerances on the holes, which makes the part cheaper. I mean, there's all sorts of things I can do. So the feedback loops that we generate, particularly between design and quality, are really, really important. And, if you really want me to pin me down on what is a real digital twin that exists today, it's really that. It's that design, engineering capture in 3D, and then the quality results. That's a digital twin. And when we can connect those together, they become very powerful. We can do statistical analysis. We can do optimization of the design. Again, endless opportunities.
Yeah, we've got some great conversation going already, and I do want to ask you guys about implementation. Some of the challenges of implementation. And we're kind of already going a little past what I was thinking, but that's great. This is good stuff. So we'll keep going for a few minutes. But one example real quick that I've heard, and this is kind of maybe getting to the edge of what's considered digital twin and what's not, but there's a very large Fortune 100 company that does, CPG. They do shampoo and all kinds of stuff like that, manufacture it. And I heard one of their digital transformation guys sharing about their digital twin implementation. And this was 2.5 or 3 years ago that he was sharing about this. And basically they created what they called a digital twin of in R&D of a part, but they made it so that they could digitally test it like completely. So for shampoo bottles, they'd be able to test if you put this much pressure on this part of the bottle, how much flow would have to go through the cap. And if they adjusted the cap this much or whatever, then it would make changes. So they were doing what they used to have to send off for samples and then get that sample and then test the actual physical product. Now they were doing that testing digitally before any product was ever made. And then they would basically cut that time down to market. He said from 3 to 6 months to 6 weeks by doing that. And then they connected feedback loop all the way to their customer service department. So then they were getting feedback from a 1-800 number on the back of the bottle that would go to the customer service. Customer service would make notes about the changes that were being made or that, the complaints that were coming in. Then they would change their digital twin, retest it, and then create a new bottle that they could then put into production immediately because they had all of that data going all the way through manufacturing and everything on that part. And so he said they're basically able to just introduce new products much faster to the market, but also have that feedback loop to change the engineering design way faster so that they're reducing complaints and returns and everything like that. And I thought that was pretty interesting.
Yeah, that's a good commercial example.
Yeah, and it probably applies to, we think a lot about part families too, and about how to reuse that data in things that are slightly different, right? So maybe it's not a shampoo bottle, maybe it's a conditioner bottle that looks almost the same, but has different properties of the thing that goes inside it. And so you've got a different set of rules. So you can take some of that data that you took from one part and apply it to the next one. Right. That's also huge. And there's a whole bunch of efficiency to be gained in that kind of small pivot in your design data as well.
Yeah, that's great. Yeah, and I'd love to keep rolling down that train, but let's talk a little bit about implementation. So if you're around the engineering space, especially, where we are going to conferences and, working through some of the being a little bit more, I wouldn't say I'm on the cutting edge of technology, but I'm keeping up to some degree with what's going on, hear about digital twin all the time. And you can't go to any conference in the engineering space without hearing digital twin and industry 4.0 and digital transformation. So, we hear that term all the time, but why do you feel like so many companies talk about it, but don't really follow through on implementing the digital twin?
How long have we got? I think they drastically underestimate the complexity of the change. Mm-hmm. I think, and we see this across industries. I can give you 5 different studies that show that if you haven't gone to your stakeholders and said, okay, have you used a computer before? All right, because there's a lot of people on a factory manufacturing line that do not use a computer in their daily lives.
Nor are there any on the factory floor.
And there's none on the factory floor. Yeah. And so you're introducing a computer to them for the first time.
Oh, wow.
Right? You're asking them to manipulate a 3D model on that computer, right? That's great if you're 19. It's hard if you're 59.
Absolutely.
Right? So if you don't take that stuff into account and build in the time and the training and the feedback loops to make sure that happens, that 59-year-old on your factory floor that's never used a computer before is going to bring this entire thing to a screeching halt, right?
And they do.
Because they have that tribal knowledge, right? Without them, you can't actually even implement your product. So,
right.
Yeah, so you've got to take the people into account, and you've got to realize the level of change that it's about. And usually people underestimate both of those things.
Drastically.
It's
a very messy change. Primarily, you said this earlier, Rhiannon, is that when we dive into what the documentation is now, because we're trying to transform it to 3D, we realize how poorly documented whatever standard processes a company may have. They're oftentimes extremely poorly documented in the current state. So you end up spending a lot of time documenting current state instead of evolving to the future. So it's a really tricky balance for people to make that leap of faith.
And it takes writing out something that in technology you call the J curve, where when you first introduce something and people are learning how to do it and it's a brand new process, everything takes longer. Because they had 65 steps in the old process, but they weren't aware of 64 of them, right? They just did them automatically without thinking about them. And now they only have 15 steps in the new process, but they have to think through how they do every single one of them. And a lot of organizations don't build in that dip in productivity and that dip in efficiency that happens as people learn how to do it. And so they hit that bottom of that curve where people have the new processes and have the new data, and they can't figure out what to do with it as efficiently as they used to do the old thing, and that everybody throws their hands in the air and walks away.
Oh, wow. Okay.
Right?
The panic is real.
And so we've got to sort of help them ride that tide. It will get much more efficient, but you've got to ride that dip first. And for a manufacturing company that's already done all its lean exercises and already done all its Six Sigma, that's really hard to take on.
Yeah.
That idea of being temporarily less efficient and moving a little less fast is hard.
Right.
Yeah, I mean, and that makes, first of all, excellent example of the people on the factory floor never having used a computer, and that being a challenge because, I mean, I am a millennial, squarely in the millennial age bracket, so I can remember using computers all the way back since I was probably like 4. We had a personal computer that I was using and playing educational games on or whatever. So I definitely take that for granted. And so if I was implementing a digital twin strategy, that would be an area that I would have overlooked for sure and learned the hard way. So that's a really great example of that. And then, the people problem, I can see that, how that really is a huge challenge. Because even in, just to kind of equate it to what I do in marketing, you have these companies, especially in the manufacturing side, that have been very sales heavy. And then as they brought in a marketing team, what they see marketing as is sales support. And so then they've had a marketing person there who's creating brochures and creating things to help the sales team, which is great. And you need that, but that's not really marketing. So then if you're going to start doing a digital marketing approach and you're going to go digital first, which a lot of companies are now having to do and having to really shift their strategy. It's kind of a similar problem where you have these salespeople who have always gone in person to their customers, and they've always had a documentation to hand out, and they've always done a PowerPoint presentation. But now you have to create all those things ahead of time, and maybe even create demand ahead of time. And it's kind of a similar challenge where when you've never had somebody do that, getting buy-in and convincing somebody, yeah, we're going to lose like 6 months worth of your marketing team's sales support help that you've always had, but you're going to see the dividends of it down the road. And without, like you're saying, without really taking that into account, you're asking for failure, because people are going to say, well, what are the results going to be next month? And it's like, you're not going to see results next month. You're going to see results in a year or two from now. And without, taking that into account, we're going to be way behind the curve. But it's really scary for leaders to take that leap.
Well, and that's where their bonuses are coming from. What happens at the end of the year, and the stakeholder value, which is the most important thing, right? That happens yearly, right? So saying, okay, we're going to take 3 years to do this great thing. Like, ooh.
Well, and often what happens is that only engineering approaches this first because they have the CAD systems. They, they're kind of coming at it from that perspective, and they make it a big engineering project. And then they spend way too much time and money, and I'm an analytical person, so I'm talking about myself as well, and too much analysis on just the tools. And they overthink the entire tool set before they've talked to the people, and they've missed big things that they've spent too much money on in the technical side of the tool sets, and not enough money on the actual like information layout, like of what the viewables are going to look like and things like that.
And the communication plan, and all of these pieces that have to support what they're trying to do.
PLM. Lots of investment in PLM and not, because if you have the guy on the factory floor who doesn't enter that information in correctly into PLM in certain context, or at least into a system that feeds into PLM, then you're not going to have the data. And if your system's relying on that data and the person who's supposed to enter it in refuses to, you're going to have huge issues down the line. Okay, so to kind of put a bow on it, because I'm sure we could keep talking for hours on the challenges of implementation. What are some practical steps companies can take to successfully implement digital twin technology?
Well, I would say get clear on what your objectives are first. We always start people with a mission and vision exercise to get people kind of grounded when we start working with a company, because often the 10 people in the room have 10 different ideas. So the first thing we do is get clear on what that is you're trying to do, and then create some clear objectives, because I have in just the design, manufacturing, and inspection space for digital twin technologies, I've identified 25 different technical capabilities you could have. And frankly, Joseph, that doesn't even include your stuff. So, just if you're going to go after 25 capabilities and you expect to get that done in 3 months, forget about it. So it's really about clear focus. I mean, this is not anything new in anybody's business at all, but be real clear, have clear objectives, clear focus about what you're going to do, and be realistic about the implementation, and go in a stepwise fashion.
Yeah, I mean, part of that stepwise fashion is be willing to do a pilot that doesn't have any production value, where you're just going to learn, where everybody's free to make mistakes,
or 10 pilots,
and learn, or 10 pilots, like, but be willing to do a non-production pilot that doesn't have a whole bunch of outside pressure on it, where people can be free to make mistakes and free to learn from what they're doing, and you've got to be able to tell the story of that pilot to everybody else in order to get enterprise-wide buy-in.
And if your plan is to stuff the information you have on a 2D drawing today into a 3D model, forget about it. Just don't waste your money. You're going to have to change your processes in order to leverage the return on investment opportunities. In some areas, we see process time savings of 80%. So if you think you're going to get that by just like doing the same old things you were doing, really?
So
no.
So I'm sure that all you guys can add in some of what I'm missing here, but you need to, first of all, not have a really clear goal of what you're trying to accomplish ahead of time, super pinpointed focus and objectives. And then you need to consider people. And if you're not really considering the people element of it and how the people who are implementing it are going to negatively affect your beautiful, perfect plan to try to get it implemented, then you're going to really run into some issues. And then start small with a pilot that doesn't have, like you're saying, the production value, where you're not putting that into your KPIs of how you're going to actually like meet that quarter's goals or whatever. And if having a successful digital twin implementation is required to meet this quarter's goals, then you're probably going to end up having some trouble. And then, that helps you to understand the challenges you're going to run into first to be able to deploy it enterprise wide, and just assume that that's going to take a lot longer than maybe we would all like in an ideal world.
Right. And then the tool manufacturers might tell you.
Fair enough.
Right.
Cool. Yeah. Well, this is really great. It's a lot of fun talking with you guys about digital twin. So the last question I'll ask you here is, what does Action Engineering do to help people implement digital twin, and at what stage of the process should they reach out to you?
Well, that's a good question. I'll say that on our website we have our proven process steps, and it generally starts out with getting some kind of executive buy-in. We do want you to do some kind of proof of concept to get an idea of what it even looks like, and so we help people actually transform a data set from 2D into 3D, and then show them what the capabilities could look like. We really, really urge that you will do a consumer adoption strategy up front before you get started, because we know that where the pushback comes is after engineering has done millions of dollars and years of work, and they go to operations and they go, here's this beautiful thing we've given you, and they go, that's nice, give me my drawing. And you're just totally stuck. So we really urge you to do that early, so that you're not wasting all your money. And then finally, we will do a kickoff workshop with you to get you started, do road mapping, and then work you into pilots, work you through the pilots. We have a number of those going on right now with our clients, and then that's going to make you have a robust adoption and get through the J curve. We're there to help you get through the J curve, because it's messy and ugly. Yeah.
Awesome. Yeah. Well, thank you so much for taking time today to chat. Really appreciate it. And
thanks, Joseph.
Yeah, we'll continue the conversation, but this is a really great, I think, introduction to digital twin to get people started and to understand a little bit more about what you can do to help them. So thank you.
That's great. Thanks. Appreciate it.
Absolutely.